This is Unit 2, Video 1. In this unit, we will talk about matter and the changes that matter undergoes, changes in properties. And properties are like the behavior or what characterizes the matter. And so we're going to get a little bit into chemistry, beginning with this chapter. Now, chemistry is the study of the composition, structure, and properties of matter and the changes that matter undergoes. The composition means what it's made of, the structure means how it's put together, and the properties, again, is like the behavior, what characterizes matter. And we'll also talk about different changes that matter can undergo, because matter will be changed in a number of different ways. That's the definition of chemistry. Now, before chemistry, there was an ancient practice called alchemy. And this came before chemistry, where a bunch of guys, usually they were guys, were kind of experimenting with chemicals. A lot of times heat was an extremely important part of their investigation, but they didn't really do it in a very quantitative way, very precise way, like we do it today. So here today, chemistry has a flask and it says 250 milliliters. It's very specific. We measure things quantitatively. But alchemy kind of led up to chemistry. A lot of their ideas were incorrect, but actually they allowed us to understand, and eventually this grew into full-blown chemistry today. So we'll talk about chemistry from now on, but alchemy helped get us here. So let's dive in and talk about the changes. And the first change we'll define is called a physical change. Now, physical change does not change the identity of the substance. And it's usually reversible, which means you can make it back to how it was. 3 examples of a physical change are cutting. So here you have a piece of paper that's being cut by scissors. Now, you're not changing the paper into something new when you cut it. You just make it into smaller pieces. A similar thing can happen with, say, a chemical crystal. Say you have a crystal and you crush it. As you crush the crystal into smaller pieces, it's still the same chemical, except you just change the size of the particles. So cutting would be a physical change. Another example is melting. Here we have an ice cube being melted. Now, the ice cube, as it melts, becomes water, but the water is still the same substance. You did not change it into a different substance as it melts. In fact, you can freeze it back up. You put it in the freezer, and it freezes right back into ice, which shows this is a physical change. And the final example is dissolving. So here we have sugar that's thrown into water and dissolved. Now, this is also a physical change because you didn't change the sugar into anything new. The sugar is actually still there in the water. And the way you can check this is the sugar tastes sweet before you put it in, and then if you mix it together, the water now tastes sweet. So because the property remained the same, it's sweet in both cases, this is a physical change. In fact, what you can do is you can put a little heat below the glass and evaporate all the water out, and the sugar will be left behind. The sugar didn't change into anything different. Now, on the other hand, a chemical change is a change that transforms it into a different substance. So here we are making it into a different substance. And usually you can't reverse this. You can't put this back to how it was. An example is a piece of paper burning. So here, as you burn a piece of paper, you're actually changing the paper into something new, something different. Usually what you change it into is ash, and then there's actually a bunch of water and CO2 that comes off the burning paper. So these 3 things are new. They're new substances, so you have undergone a chemical change. Iron rusting is another example. So here we have iron as a metal, and as the metal rusts, you've got this orange-brownish substance that forms on top of it. Now, this is actually a powder, so it has a different texture than the original metal. The original metal was nice and solid and firm. Now it's a powder. It has a different texture, it has a different color, so you know you've produced something new. What you've produced here is actually something called an oxide of the metal, and that oxide has different properties, so that this has been a chemical change. There are many more examples, which we'll talk about, of a chemical change. Now, there's an important law that we must mention, and that's the law of mass conservation. This law applies to matter. It's fancily called the first law of thermodynamics, which is of all chemistry, science, physics, biology. And it says that matter, which includes mass, because the definition of matter is something that has mass, is neither created nor destroyed in chemical or physical changes. So an example of a physical change, again, this is a physical change, is water evaporating. So we have water in a glass, and then if you heat it up, maybe use the sun, or you don't have to use the sun, you kind of set it out, the water evaporates and you lose an amount of water. Now this amount of water actually went into the air, and if you capture it and measure how much it is, it'll be exactly the amount that used to be here. So you never lost any, you never destroyed any matter, it just went to a different place. An example of this with a chemical change, so this would be a chemical change, is a chemical reaction that occurs in a flask. So notice they put a substance here, there's a liquid, and then there's a solid here in the test tube, or maybe two liquids actually. And they measure the mass to be 300.23 grams. They closed the container and then shook it up, let the chemical reaction take place, and after it's done, we weigh it again, and of course, the mass did not change, because as a definition, mass cannot be destroyed or created. So if you keep the container closed, you'll see this law in effect. Now, let's talk about properties. Remember, a property is something that describes the substance, and properties that can be observed or measured without changing the identity of the substance would be a physical property. An example of this is saying that carbon dioxide is a gas. You're simply describing carbon dioxide, but you're not chemically changing it. So here is a canister or a container of carbon dioxide used in paintball guns and other applications. So if you don't change it, that would be a physical property. Whereas a chemical property is a property that you're observing and requires the substance to undergo a chemical change. So anytime you say something is flammable, for example, acetone, which is in this big bottle, can be easily purchased at your local hardware store. And if you check, acetone will ignite. Now, as you're checking whether it ignites or not, you're changing acetone into a different chemical. So this property is a chemical property because you're changing it into something different as you're observing it. Now, an important statement to make is that all chemical changes will involve energy. Most chemical changes will actually release energy, like in the example of acetone being flammable. Some chemical changes absorb energy. Those are a little more rare, but there always is a chemical, or there is always an energy change, usually a heat change associated with a chemical change. So here is an example for us to go through real quick, and then you'll have one to try on your own. It says classify the following changes as physical or chemical. The first change is baking soda and vinegar reacting and producing carbon dioxide gas. Now if it says producing, that means we're making a new chemical. Since we're making a new chemical, this has to be a chemical change. Hopefully you've performed this reaction when you throw baking soda together with vinegar, and the bubbling that you see in the reaction is producing a new substance that was not there before, and by definition a new substance means chemical change. B says we're going to cut metal into two, which means the metal is still the same substance, you're not changing it, so this would be a physical change. And you can melt the metal back together easily. C says acid eating away at a metal. Now anytime you put metal in an acid, the acid will eat away at it and the metal will dissolve in the water. Now because the metal dissolves, its properties change. It's no longer metallic, it's no longer shiny, which means you've changed it, which means this would be a chemical change. Now this is a little different than dissolving away sugar, because sugar was powder before, you can recover the powder after, but if you try to recover the metal, if you boil away the acid, the metal won't be there in terms of the shiny metallic piece. It'll actually also be a powder, so you've changed chemically the metal. And then finally, water becoming ice in the freezer. This is the opposite of melting, so it's still water, you didn't change it, so this is physical. So hopefully these made sense. Go ahead and pause the video and try practice problem on your own. And now let's finish talking about extensive and intensive properties. This will be a little tougher to understand, but bear with us. An extensive property depends on the amount of matter that is present. What we mean is mass. Think of mass. You have two big blocks of metal. Here is a bigger block. We'll say this block is 10 kilograms. We'll say the smaller block is 3 kilograms. Now the mass is different. If the piece of matter is different, if the size of the matter, the amount of matter is different, and the mass is different, then the mass depends on how big the piece is. It's extensive. Another example is volume. We'll say that this takes up 3 liters. We'll say that this takes up 1 liter. And so what you've got is the piece got smaller and the volume got smaller, which means volume depends on how much matter you have. So matter or mass and volume are extensive properties, whereas an intensive property does not depend on the amount of matter present. An example is melting point. So pretend we're going to take this and heat it up until it melts. And we're going to apply a Bunsen burner to it and say it melts at 800 degrees Celsius. Now the question is this: if I take a smaller piece and also heat it up until it melts, at what temperature will it melt? Well, it's also going to melt at 800 degrees Celsius, because it doesn't matter how big the chunk is, it still melts at the same temperature. If you think about the same thing with a glass of water, a little bit of water versus a lot of water will melt, or boil rather, still at 100 degrees Celsius. So melting point will be an intensive property. It doesn't depend on how much you have. Density is a very famous intensive property because as you make a big chunk into a smaller chunk, its density does not change. You've changed the mass went down, but the volume also went down. So density is mass over volume, so the two actually cancel each other out and you end up with the same density. A small piece of metal, this piece of metal right here, will have the same density as this big piece of metal. And we've discussed density, so hopefully this makes sense. Alright, this wraps up for us Unit 2, Video 1.